Hey, expensive cameraman, where do electrons get their supplies from? The Home Depot. You get it? It's funny. Don't shake your head now. We're rolling? There are one of two ways in which electrons can flow in a wire, through a direct current or an alternating current. In direct current, or DC, negatively charged electrons move in one direction to an area with a positive charge, like from a battery. You see, batteries have chemicals in them with lots of electrons on one side. The other side is electron hungry. If the wires are connected, we say this circuit here is closed, and in any closed circuit, electrons from the negative end can travel in one direction all the way to like a bulb, heat up the metal inside the bulb, cause it to glow, and then wind up at the positive end until all electrons are distributed and the battery becomes neutral and is dead. Devices like flashlights, cars, and cell phones usually run on DC current. If you open the circuit, electricity stops flowing. Why? Well, free electrons can't move anymore. But in an alternating current, or AC, electrons move in one direction for a bit, and then change direction, and then change again. Electrons act like this in alternating current. They're being pushed in one direction, and then the other direction, and then again. They're alternating their direction. Actually, the total movement of these electrons is zero, but traveling back and forth still provides us with energy and many advantages. AC current allows for electricity to travel in far distances without the risk of heating up the wires too much, and the ability to change the voltage as needed. If you had the time, Google the current war, the fascinating history behind Thomas Edison and Nikola Tesla's rivalry with DC current and AC current. Alternating current powers your homes, your town, and this entire country. Ooh, take a look here. This socket allows an alternating current to flow into a device. This smaller hole on the right is for the red or hot wire. That's where current initially comes in. This larger one is for the neutral wire to complete the circuit. Remember, all circuits must be closed. Now, metal must touch metal for a complete loop for electricity to flow. So, if you plug in a device, the electrons will move back and forth, alternating their direction through this small hole, into the prong here, through the device you're running, out through the other prong, and into that larger hole in the outlet, completing a closed loop. So how fast does AC current alternate back and forth in this system? Extremely fast. In fact, in the United States, alternating current switches 120 times every single second. So what does that mean for you? Well, believe it or not, your kitchen light is flickering on and off 120 times each second, but that's so quick your brain doesn't even notice it. Whoa! It's like Barry Allen fast. The Flash. Wally West? Never mind.